Hi, this is Mrs. LaBarbara. This is Physics Chapter 11, Wave Behavior, Video 3. Today's topic is interference of waves. Objectives are: know the definitions of interference, understand how waves constructively or destructively interfere, be able to select or sketch interference patterns for two waves, be able to determine situations in which minimum or maximum constructive or destructive interference will occur. Wave interference is a phenomenon which occurs when two waves meet while traveling along the same medium. The interference of waves causes the medium to take on a shape, which results from a superposition of two individual waves. Superposition means addition. Take a look at these two animations. These are two pulses travel toward each other. When they meet, you'll have a new shape in the medium. But after they met, after the two waves meet, produce a net resulting shape of the medium, they will then continue to doing what they were doing before the interference. Take a look. The big one travel to the right. Afterwards, it still travels to the right with the same shape as before. Small one goes to the left, after still goes to the left after the interference. So there are two types of interference. One is called constructive interference. Constructive interference occurs when the two interfering waves have a displacement in the same direction, resulting in a larger amplitude, like what we saw before. That is an example of constructive interference. Here is before interference. This is during interference. So the shape in the medium is just gray. You won't see the red and the blue. It's just gray. Now after they will traveling in the same way. The red will go to the right. The blue one will go to the left. And same thing can happen for trough and trough interfere. You have a bigger trough. So when is a constructive interference occur? Constructive interference occur when waves are in phase. That means they are 0 degrees or 306 degrees apart, or 1 lambda apart, or 2 lambdas apart. One wavelength or 2 wavelength apart, and so forth. On the other hand, destructive interference occurs when the two interfering waves have a displacement in the opposite direction. So destructive interference results in a smaller amplitude. The maximum destructive interference occurs when the two waves of equal frequency and amplitude whose phase differs for 180 degrees or half a lambda. That means they are exactly opposite. So maximum destructive interference result in formulations of nodes. Nodes means the place of zero displacement. Okay, so this green line, this is all nodes. All the points on the green line are nodes. That means it's flat. There is no displacement at all. So here is another one. It's just regular destructive interference resulting the green one is a smaller amplitude. So the graph on the left says maximum destructive interference resulting in the nodes or smaller amplitude. That's destructive interference. Constructive versus destructive. So constructive result in bigger amplitude. Destructive interference result in 0 amplitude. Let's take a look at this. Destructive, the two waves, the same. Constructive. Okay, so between constructive and destructive interference. Let's take a look at this example. What type of interference in each section? Section 1, 2, and 3. Section 1, you'll have a red wave and blue wave. In section 1, both waves are upward, so their amplitude both are positive. So this side is going to result in bigger amplitude. So number 1 is constructive. Number 2, the red and blue are always opposite, in the opposite direction. So this, in this case, will result in a smaller amplitude. So this is destructive. And the last one is again constructive, because blue and red in the same direction, they are both negative, will result in bigger negative. So that's constructive. Principles of superposition. So when two waves interfere, the resulting displacement of the medium at any location is the algebraic sum of the displacements of the individual waves at that same location. So here are two waves. How do we add them together? We add them. For example, the first point, both waves has 0, so the result is 0. The second one wave has 2, the other one has 1.5, so result is 3.5. And the third point, one wave has 2 amplitude, the other wave has 4 amplitude, so the result is 6 amplitude. And over here again, about 4.5, and this is 0. Basically, you add point by point. Then you connect the dots. Okay, so this is your resulting wave. Hi, here is another example of adding waves. So here is destructive interference. You add point by point. So the 2.0, 0 equals 0, positive 1, negative 1 equals 0, 0 and 0 is 0. So you get a nodal line because all the points on this line is node. For example, let's take a look at how do we add a sine wave and a square wave. We use the same principle. So we use point and a point. So here is a sine wave, here's a square wave on the bottom. These 2 points add together will give you this 2. It's a 0 and a negative 1 at the same time. So it's a straight line. The next point we choose, this 2 points, it give you positive 1 and negative 1. So you get a 0. And this point is 0 and negative 1, so give you this point. You simply connect a line. So that's the result of these two waves interfere together. Another example. So here are the two waves. How do we add it? So again, we use superposition principle. We add point by point. 0 and 0 give you 0. This is negative 1. This is positive 1.5. We get 1.5. Positive 2 and 0 give you positive 2. 1.5 and 1 give you 2.5, and so forth by adding each single point. So this is the wave we will get. So this is the resulting wave of interference of the top two waves. Interference pattern of two same waves in phase. So if you have two same waves, such as water waves, part of one going over here, part of two going over here, this wave is going to diffract. So is this wave going over opening is going to diffract. Because diffraction, these two waves is going to meet. And when they meet, interference is going to start. So constructive interference is when a crest meets another crest. Destructive interference when crest meets with trough, producing nodes. So constructive interference producing a point called antinodes. Antinodes is constructive interference, and nodes is destructive interference. So although both sources are repeatedly producing waves which move across the medium, a stable pattern is produced. So this one vibrating up and down, but over here looks like pretty stable, right? The region of constructive interference do not really move. This section is always constructive interference. And dark lines are also do not move. This dark line is called the nodal lines. This is the dark lines is due to destructive interference. So we can actually measure the distance between the dark lines to figure out what the wavelength about the source wave. So this is interference pattern of the two waves, same waves in the same medium. Let's take a look at this example. The diagram below represents a shallow water wave of wavelength lambda passing through two small openings and being a barrier. How much longer is the length of path AP than the length BP? Let's take a look at AP. How many waves is that? A wave is crest to crest. So over here, you start with kind of small crest, right? You can't see. So here's one wave, two waves, 3 waves, 4 waves. So AP has 4 waves. Let's take a look at BP. BP has 1 wave and 2 waves, so they are 2 lambda apart. As you can see, at point P, it's crest over crest. So at that point, it is constructive interference. Also because the difference is multiples of the wavelength. That's why it is constructive interference at P. If you look at another point, for example, this point is a trough meets with a crest. So this point is a destructive interference at that point. Sound interference and beats. So when the sound wave meet, interference occur. Constructive interference will produce a louder sound. Destructive interference will produce no sound. You see, like construction workers have those earmuffs, and that can produce the destructive interference, so there is no sound at all. So it's a noise reducing system. So when sound waves with slightly different frequencies traveling in the same direction, the effect of interference is a perceived variation in loudness. It's like this. Here, this section is a louder sound. Over here, this is no sound almost, and louder sound and no sound. So this is called beats. So this looks like a transverse wave, but this is actually the representations of sound wave. So we use a program to change sound pressure to this vibrating transverse wave to have a visual. What happens when the single-colored light interfere? The single-colored light interference will produce bright and dark fringes. Here's a light coming. This is a famous Young's interference test. And part of light go here, and they interfere. They produce the bright and dark spot. A dark spot is destructive interference. Bright spot is the constructive interference. Constructive, destructive, constructive. So we can also measure the distance between these two to figure out the wavelength. And if we also measure the opening, the size of the opening. Now you're probably very familiar with soap bubbles. These soap bubbles, the color you see on the soap bubbles are the results of light interference. So bright colors seen at some of the soap bubbles are caused by interference. The brightest color are those that interfere constructively. So you see the color because the purple had constructive interference and the green has constructive interference. If you don't see the color, that's because those colors has destructive interference, so they cancel each other out. So how does this happen? Light strikes a thin film, is partially reflected. This is ray 1, and partially refracted goes in. That's the light that's bending inside the film. But when it comes to the surface B, again, part of it is reflected, and this reflected will refract into the air. When these two waves interfere, you can see the color. So what color you can see depends on the thickness of the film. So at different parts, that's why at different parts of the soap bubble, you'll have seen different colors because the thickness of the soap bubble is not even. So some parts may have yellow colors or red colors because at that position, those colors interfere constructively. And at other parts, you may see purple colors or green colors because those other parts has interference constructively.